Okay, so the objectives today, we'll analyze pressure throughout a layer of fluids. We kind of did that last time, but we'll do another practice problem, and then define barometer and a manometer, and we'll do a practice problem. So let me put it right there. So we want to calculate the air pressure above the gasoline. So anybody want to guess how we start this? Where do we go from here, and what do we do? So I'm going to label this right here, PA. Label this as PB. Label down here as point C. And these are point B, and this is point A. So we can label that PC, sure. Label that point D, and we'll call it PD. And finally, this point here, we'll label E, and we'll call it PE. So just to save space, I'm going to write my givens on the right-hand side. So is that given? Yes. Okay. So SG of the mercury, SG of the gasoline, SG of the water. What's the specific gravity of water? 1. Yep. P atmosphere. I believe I used 101 kilopascals. And then I think I actually defined H values. And again, I'm going to save room here. Find PA. Oh, why don't we throw in the density of water to be 1,000 kilograms per meter cubed, and G is 9.81 meters per second squared. Throw in some assumptions to help you start preparing. Incompressible, yep. There you go. They don't mix, yep. Fluids don't mix. Because if it mixed, then you'd have to find a new density, right? And we're not going to do that. Alright, so I'm going to do it my way, okay, and to show you. So let's start the solution down here. So what I'm going to do is I'm going to start with PB equals PA plus rho of the gas times G times H1. Anybody want to know why I started there? We're looking for PA, right? So find the equation first that has PA in it. And always write it so it's the bottom pressure equals what? Top plus rho GH. Always drive that in your head. Don't worry about negatives at all yet till you rearrange, okay? Trying to drill that in your head. Always remember, bottom equals top plus rho GH. So yes, what we're going to do now is we're going to rearrange for PA. Then, if you're going to sub in SG equation, just tell me. Okay? So it's PB minus SG of the gas times rho W times G times H1. We're going to do this a couple more steps, and then we'll finally plug our numbers, okay? And I'm going to call this equation 1. I'm going to start a new heading. So what do we not, then again, we now need to find what? PB, right? So if you notice, we're going to start from the right top and go all the way down and all the way kind of bring our back self to the left. Okay? So let's go back up here. Give me one equation that you could use to find PB. That's the top pressure. What's below that? PC, or you could do PD, right? Because it's the same fluid, because it's all water here to here. So technically, you could just add that and that depth. Okay, because if you looked at the equation, it's the top pressure plus rho GH. Only affects height. So for as long as you have the same fluid, you can just add those two heights together. Okay? So PD equals PB plus rho of the H2O times G times H2 plus H3. And then here, I'll rearrange and solve for PB. And I call this equation 2. And now, we need to find what? PD. And it won't be this class, but in next class, I'll show you the shortcut. Okay? But it's good to know this first. So I'm going to write the equation, write it down, and we'll discuss it. Looks like most of you have it. I'll go back. So let's go up here and just talk about how we can do that. So the previous one, we found that this pressure right here is the top pressure plus rho GH. All right. Now, because this is a mercury-water interface, there's mercury here. That pressure, because this is all mercury here, is the same right here as you jump across the leg. Okay, because it's the same fluid, it's the same pressure. And if you knew this distance here, and you calculated this pressure here, and then you went back up the same distance with the same fluid, they're going to be the same pressure. Okay, bottom line, that's how it works. So right here, technically, we could also call what? Point D, because it's the same fluid. And so the bottom pressure equals the top pressure plus rho GH. Okay? And that's how we got that equation. And what did we say PA was? What am I going to do here? So I'm going to say sub PE equals P atmosphere and the SG equation. P atmosphere plus specific gravity of mercury times rho of water times G times H4. And I called this equation number 3. And now we can sub, right? We have everything. Everything on the right side is in our givens. So sub. And I'm going to put equation number 3. So PD equals 101 kilopascals times 1,000 pascals and 1 kilopascal plus 13.54 times 1,000 kilograms per meter cubed times 9.81 meters per second squared times 457 millimeters times 1 meter, 1,000 millimeters. Okay, keep going, right? Because now we can solve what? Equation 2?
Why did you use rho W instead of rho F?
This part right here?
Yeah.
That is the specific gravity equation. This is the density of mercury. And then that right there, so I kind of skipped a step, right? That right there is the density of mercury. Okay? So technically, this is what? What's the specific gravity equation? I'm actually glad you did this. It would be density of mercury over density of water, right? So Jerome asked this question, should we write that? And actually, that's good. You should write that right now, every time you do your homework, to drill that in your head. Later on, you'll remember, as long as we have specific gravity, we can multiply by the density of water, which is 1,000, and get it. What's the density of water in English units? Remember? No one remembers? What are the units? Give me the units at least. No one remembers the units?
Pound mass per liter.
You probably could. That would be a messed up conversion. Yeah. But what do we typically use? Yeah, cubic feet for the volume. Yep. But what is the either pound mass, like you guys said, or slugs? So always remember density of water as 1.94 slugs per feet cubed. Because when you include that in your units, you'll end up getting a pound force at the end. You don't have to do that weird conversion. Okay, so let's solve equation 2, which is PB equals 161702 Pascal minus 1,000 kilograms per meter cubed times 9.81 meters per second squared times 381 millimeters times 1 meter. Now you don't have to do the conversions here. You can do them in your givens. I just wanted to show you. 148,154 Pascal. And then finally, you can now sub equation number 1. And again, I'm okay if you want to use colored pencils, sure, to help you identify stuff. Okay, so I just want to quickly show you a few things that were used to measure pressure. Okay, all right. A lot of it, you can measure your blood pressure. You can measure just random fluid pressures. Okay. Let's see, is this going to work? No, it's all right. Okay, so the first thing that measures atmospheric pressure only are called barometers. Okay, So basically, this is the fundamental concept of a barometer. In here, it's a pretty much, we can almost consider it a vacuum. The pressure is zero. And atmospheric pressure is right here, pushing down on the fluid here, which then can raise or lower this liquid depending on when the pressure changes. Okay? So, if this is mercury interface here with the air, what's the pressure right there? It's whatever the atmospheric pressure is because it's at the same elevation across. Okay? This is mercury, the interface. That has to be the same pressure because it's the same fluid. So, if we want to know what this pressure is, what's the top pressure? 0. So the top pressure plus rho GH. Yep. So technically, if you have a barometer at your house, as long as you know the density of whatever that fluid is and the height, you can find your atmospheric pressure. Because we can assume that's a vacuum. It's just 0, but actually it's not 0. Who can tell me what that pressure actually is up here? We have covered it. What happens when liquid evaporates?
Vapor.
It turns into a vapor. Therefore, what is that pressure? The vapor pressure at the temperature. Yep. Okay, because some of this liquid has to evaporate up there, right? To a vapor. So technically, you can go in the back of your book, figure out what the temperature is, and say, that's technically the pressure up in the top. I'll do a bonus. Take a glass of water, not a cup, because I want to see through it. You fill it halfway, 3/4, whatever, not all the way, and you flip it upside down on a piece of paper, and then you put the paper on the table. If you take a video of that and show me, I'll give you extra credit. Okay? It will not spill, unless you got to kind of be fast, but you can flip it upside down, and it's pretty cool. All right, and then we'll talk about it in a little while after, maybe a couple classes. Okay, so if you do that for extra credit, do that, take a video, send the video to me, I'll give you extra credit. All right, we'll talk about it in a couple classes. It's pretty cool. I've had a few students do it before in the past. All right, so what does a barometer only measure? Atmospheric pressure only. Okay, then we have what they call manometers. All right, these measure a change in pressure. Okay, here we have a vertical one where this and this are hooked to either like a pipe or two different places to measure pressure. And this is what they call an incline one. And there's a port here and another port here. Okay. So as this liquid level changes, we can then figure out, based on that liquid change, the change in pressure, and we can use that in other calculations. Okay. So we're not going to do much with an incline, but we are going to do a lot with vertical ones, okay, that change your height. And you got to know how to do this first, because later in the semester, we're going to show you how to calculate volumetric flow rate, and we're going to do an experiment down in the lab with Venturis, and you have to know how to calculate the change in pressure. As long as you know the change in pressure between 2 points in a pipe, you can convert that to how fast the fluid is moving. Very important for pump flow and pump sizing and all that. Okay. So those are more of a mechanical liquid level changing. You also have these types of what are called pressure transducers. What happens is this is a pipe and the fluid is in here, and depending on the pressure, it changes this location of the link, which therefore changes where this needle is. It's pretty cool, all right, how that works. Okay, so this is more of a mechanical aspect of how you can calculate what the pressure is. And once they make this, what they do is they use that with a known calibrated pressure sensor to figure out what this scale should actually read in the correct scaling. So they have to calibrate the new instrument that they get. Okay. So that's pretty cool. You also have these magnetic ones. They're in the lab. Okay. You change polarity and stuff. We won't do too much with that. Also, you'll see some of these that have strain gauges, little resistors, and you can figure out how much this little beam bends and correlate that to pressure. Okay. You'll cover some of these later on, especially intermediate. We'll do pressure sensors, and we'll talk more about it. But just wanted to give you, there's a brief introduction in your book about these different types of pressure measurements that you can read up on. Okay. But for you, the biggest thing is going to be manometers and barometers, knowing the basics of those. Okay. Well, all right. So here is a manometer. We want to figure out the change in pressure. We'll do PA minus PB. All right. So the first question is, where do we start?
Givens.
Okay, good. That was my test. If you are stuck and don't know what to do, you just write your givens down. So let's write some givens. SG of the oil, 0.85. SG of the water, 1.0. Oh, I called H1 33 inches. Oh, we're doing English. Great, right? Ka-ching, is that what I heard? Can you, sure, you can change it. Am I going to change it? Nope. But you can. You can convert everything you wanted to SI. I don't care. But I'm going to keep it so I give you more practice. Uh, 33 minus 8 plus 12 equals 13 inches. So what is that one? I just made that up. Was there something we were missing? So this I called H1. What I call 8 inch? H2. Okay, so that is what I called what? HY or H4. Yep. Yep. Density of water. Oh, I did convert them. So I did convert. So I used 1,000 kilogram per meter cubed. I converted in my givens. So I lied to you. Sorry. All right, we're finding PA minus PB. Put some assumptions here. Pretty much are incompressible and fluids don't mix.
What is the
I am going to show you the shortcut. So I'm going to put find PA minus PB, and I'm going to label it the shortcut.
Are we allowed to use the shortcut?
You can. Yep. But if you're always stuck and don't know, you can always do the long way. So I'm going to write the equation, and we're going to go through it. So, let's talk about this. Shortcut for the manometers. what you do is you just pick a starting point. All right? And I would actually label it. So we're starting at what? At point B. So when you start, you just write your pressure down. Boom. Then we have to determine, are we going up a leg, which this is a leg and that's another leg over here, or are we going down? So we got to go up. So you write negative. And what is the column of fluid until you get to here? Water. So write rho GH. Next, this is oil. That whole loop is oil. So that's the same pressure, right? Now we're going to go from this down the leg. So we add. So, good question. So let's review again. We started at B. We went up the leg of the fluid. And then we wrote negative rho GH. We got up here. This whole curve to here is oil. And then I say, okay, that's the same pressure. I'm going to go down the leg. So I add the density of oil, the G and the H value of that section. Then I'm here. It's a new fluid going down the same leg. So I add rho GH of water. And then finally I reach my destination. I set it equal to PA. So if you started at A, you would get this, exactly what you said. PA minus rho of water, G, H4, minus rho of oil, G, H2, plus rho of H2O, G, H1, and you set it equal to PV. Why did I want to start here, though? Because what are we looking for? A minus B. That's easier to move this over there than rearranging this. I mean, it's up to you. It doesn't really matter. I mean, I guess we could have moved all of this over here and then brought that over, right? So when you get the answer, you could try this. You end up getting PA minus PB to be negative 3.29 kilopascals. Does that make sense? It's just saying PB is what? It's greater than PA.